can see the scoring calibration provided to our participants and judges as well. We also want to thank our volunteers and sponsors for hosting 3MT and making this possible. And I'd also like to introduce our judges for Heat 2. We have Ms. Tracy Locus, Assistant Vice President for Financial Aid and New Student Service Initiatives. Dr. Barragan, Associate Dean for Research and Professor, College of Science, Dean's Office. And Dr. Robert Stackman, the Associate Vice President for the Jupiter Campus. Our first contestant is Dominic Gold from the College of Science. He will be presenting on homomorphic encryption, will it save the world and your privacy?
As the march of technology progresses, our personal lives continue to be exposed to corporations and governments at large to create fantastic products that we use every day. Restaurant recommendations utilize geospatial information, but we may not wish to disclose our location. Fingerprint data and facial recognition is used to unlock our phones, but we may not want a raw copy of those biometric authenticators existing on the server. Heart rate data collected from Apple Watches and Fitbits monitors our heart rate and gives direct implications of our daily actions, eating, sleeping, walking, exercising. But in fact, there's even current cutting-edge research that uses the correlation between brain activity and heart rate as a non-invasive method for seizure forecasting. And while we would love to be able to predict this event happening in real time, we wouldn't necessarily want the server collecting the data to know that information. And so while these products are fantastic and society as a whole benefits from them, the methods used to train them expose our individual privacy that we wish to maintain. Yet, all of the products just mentioned are simply computer models that ingest data and output a result. Thus, the question I am researching is, how can we create and train these marvels of human innovation in a way that doesn't expose our data and thus maintains our privacy? My research question, then, is answering this by using a technique from cryptography known as homomorphic encryption. Homomorphic encryption, the forefront of it, enables addition and multiplication on encrypted data directly. Using these building blocks, I was able to classify an encrypted object into one of 3 distinct shapes with nearly 100% accuracy. But that was just the beginning, as I was also able to implement the matrix multiplication needed to enable encrypted neural networks for prediction and classification on encrypted data. All of this is done such that the server performing the computation never sees anything about the data nor the result itself, thus ensuring the data provider's privacy the entire time. While there is literature plus my own implementation of these models, these encrypted models, there exists a branch of data science known as topological data analysis that has not yet been explored by cryptographers. By studying the underlying structure and shape of the data itself, TDA has seen overwhelming use and success in the biomedical data sphere, which houses some of our most sensitive data. My research then lives at the intersection of these 2 burgeoning fields, both with the aim of combining both fields into the field of encrypted data science, as well as adapting TDA to the homomorphic encryption framework. So the next time you want to find out if that skin blemish is a mole or melanoma, you won't have to use WebMD. Feel free to take a picture and upload it to a trained skin cancer detection model online, but don't trust the data scientists that made it, and make sure to encrypt your image first. Thank you.
Thank you, Dominic. That was amazing. This is my first time participating in 3MT, so I'm very impressed to see anybody speak that much about a subject in that time period. So very, very well done. Next up, do we need a couple minutes? Okay. I also forgot to mention, if you do want to take pictures, please feel free to do so. No flash photography. We also want to make sure that there's no interfering presentation from audience members, and that we are going to be providing marketing and everything from this event as well, so your presentation should be available online. I think we're going to have a couple minutes for the judges to get settled, and then we'll bring up our next contestant.
Yeah, absolutely.
All right, our next contestant is Hayley Knapp from the College of Science, presenting From Poop to Parent, examining paternity and dynamic Atlantic spotted dolphin populations in the Bahamas. Hayley, are you ready?
I used to work with penguins at a zoo. And if I learned one thing about those super cute but super smelly birds, is that they are phenomenal projectile poopers. And when I say projectile, I mean it shoots far and it lands on everything and everyone. So if you're wondering if I've ever been the target of projectile penguin poop, the answer is yes, I have. And as it turns out, that's not the last time I would be in the path of an animal's poop. You see, nowadays I study dolphin poop. Except it doesn't accidentally land on me. I have to swim through it to collect it. But why do I study dolphin poop? What can it tell us? Turns out, quite a bit. You see, your poop contains cells that have been shed from your intestines, and those cells contain DNA. The same is true for dolphins. That non-invasively collected DNA can tell me things like the paternity of each individual. So with the help of the Wild Dolphin Project, I am studying the genetics of Atlantic spotted dolphins. The Wild Dolphin Project has been studying spotted dolphins in the Bahamas for nearly 4 decades. But in 2013, on one of their trips to Little Bahama Bank, they could find them. After a month of searching and over 160 kilometers south, they found them on Great Bahama Bank, where they also found a second population of spotteds. This exodus presents a unique opportunity to study how 2 populations interact after something like an ecosystem crash drives them together. That's where I come in. By extracting, isolating, and amplifying the DNA from fecal samples, I am able to examine short, repetitive DNA sequences called microsatellites. These microsatellites can then be used to trace paternity, so we know which males are successful in siring offspring. This is important because dolphins are very promiscuous creatures. They will mate with whomever they want and whenever they want. But now that these 2 populations are living together, there is an increased chance for mating. which means increased gene flow and increased genetic diversity. Recently, the Wild Dolphin Project discovered that the two previously aggressive and hostile populations are now socially merging. And because they have observed courtship among individuals from both populations, it is expected that my results will demonstrate a genetic mixing that is driven by the males who are encouraging these social interactions. This is important because as climate change continues to drive animals to migrate, social interactions will increase. And if they're genetically mixing, they're more likely to survive. So even though no one likes to talk about poop, it can tell us a lot about dolphins. Thank you.
Yeah.
Thank you, Hayley. I never thought I would read poop as the first word in the presentation. But I'm glad I did. That was very fascinating. Thank you so much. Again, we're going to do a couple minutes for the judges to get their scoring, and then we'll have our next contestant compete. Thank you guys.
That slide is going to be everywhere. And that's we're all back there. So I can see it all. And that's not obviously most kind of everything.
Our next competitor is Hugo Pimental from the College of Engineering, presenting on chasing maximum power of water wheel onboard unmanned vessel. Hugo, are you ready?
Over the last few years, drones have made it out of the hobbyist market into professional applications such as remote monitoring of coastal environments, track beach erosion, water conditions, and sea mammal populations. So now we have drones remotely tracking coastal areas and intercoastal waterways, providing scientists high-quality images and other environmental information in perfect scenario. There is, however, a fundamental problem here: drone battery life. You see, we have thousands of miles of coastline and drones with maximum flight time of 30, maybe 40 minutes. So we need at least one charging station to survey those locations. Inland charging stations are static and cover only a fraction of the area of interest. Both mountain charging stations, however, cover a much wider area, since navigation is possible, but have higher costs and rely on fossil fuels. So how can we solve this issue? Our research team proposed a novel idea: an autonomously operated surface vessel equipped with a drone charging platform that self-navigates to different locations on the coast, which allows the drone to recharge while also increasing the area the drone can survey. There, problem solved. Where's the power to charge the drone coming from? That's where my research comes in. A water wheel turbine attached to the back of the surface vessel captures power from water flowing past it. That way, we have a renewable source of energy feeding our system, thus eliminating fossil fuels. The beauty here is that to deal with variation of flow speed, our system shifts gears, much like a bicycle rider when trying to go faster or climb a hill. If the water flows too slow, we shift gears down, make the water wheel feel lighter. And if the water flows too fast, we shift gears up, make the water wheel feel heavier, and increase power production. Our control system tracks how much power is being produced, and by using an algorithm called hill climb search, it shifts gears and finds the optimal gear where the system can output its power production. That way, we make sure that we're always capturing maximum power from the flow, thus increasing the battery, charging the battery efficiently. Tests have shown the system to shift gears efficiently until it finds an optimal ratio where maximum power output is achieved. To sum things up, with this research, we expect to solve the drone flight time issue, and hopefully we can shine some light into the future of autonomous systems. Thank you very much.
Thank you, Hugo. That was very well done. Thank you very much. I love seeing how many, I'm not from Florida, just to give a little bit of background on me, so I love seeing all this research happening near the water, since I'm from a very not landed state. Yeah, it's been an amazing experience so far. So we'll get a couple minutes to have the judges wrap up their scoring, and then we'll have our next contestant. Thank you guys again. Our next contestant is Ingrid Santillan from the College of Engineering, presenting on corrosion is in the air. Ingrid, are you ready?
Generally, structures are designed to last 50 years. While it is well known that many structures can last for longer than that, in Florida, structures are exposed to harsh marine environment, which reduces that time instead. Most beaches around Florida are made of reinforced concrete. Reinforced concrete has embedded steel. Concrete is an alkaline material that has a healthy environment for the embedded steel. However, concrete is also a porous medium, so when exposed to marine environment, the particles in the air penetrate through the pores of the concrete. Reinforced concrete structures in Florida have a common challenge: corrosion. Corrosion is an electrochemical process that affects the steel. Now, if we get technical, corrosion is not in the air. Marine aerosols that contain chlorides are in the air. Marine aerosols generate in the ocean and they transport through the wind to the structures. In the surface, they penetrate and then they enter through the pores of the concrete, reaching the steel, and that is how corrosion initiates. Now, there are 5 different stages of corrosion in all the structures. The splash zone is known to be the one that has the highest corrosion rate. where in Florida, we have observed ridges that have corrosion at the atmospheric zone. So the main objective of my study is to understand the corrosion at the atmospheric zone in ridges exposed to the ocean. For this, we obtain cores from ridges exposed facing the ocean, and we analyze the amount of chloride that penetrate through it. Another goal of this study is also to measure the salinity in the environment through a wet candle test. This test allows us to measure how many chlorides are penetrated in the ridge in the environment. So now we have two sets of experimental data results. One are the samples from the ridge, and the other one is the environmental data from the wet candle testing. When we correlate them, we will be able to understand the trends of how these chlorides present in the environment in Florida penetrate at the atmospheric zone. Now, there are many things that can be involved into the penetration of the chlorides. One of them being the wind direction and the wind speed. We are also considering the weather at these particular locations of the three bridges, as well as the geometry of each bridge. How this study will impact in the design of bridges? Well, by understanding how the corrosion happens at the atmospheric zone, we will be able to promote better design of the bridges, safety, and as well cost effective. Thank you.
Thank you, Ingrid, very much. That was very informative. I lived in Pittsburgh for a while. It's a city of bridges, and I think every bridge needs to have probably exactly that look that from corrosion. It's amazing that you're all learning these fantastic things to help our infrastructure around the world. So we're going to have our last contestant in a moment. We're going to allow just another minute to wrap up their scoring. And again, thank you all very much for participating. And yeah. I apologize, two more left. Okay. Our next competitor is Samuel Shaffer from the College of Engineering, presenting a comparative analysis of rebar corrosion using ultrasonics with poroelastic modeling and traditional techniques.
Yeah.
Living in South Florida, we all have bridges down here. A lot of us drive to and from work and have to cross them. So one thing about environments like Florida is that corrosion is a detriment to our bridges and our structures. Now, bridges are used and made of reinforced concrete structures, meaning that we have steel embedded within concrete. And so monitoring the corrosion levels of these bridges is important so we can monitor the overall health and determine whether or not these structures are stable or not. Now, common techniques for monitoring corrosion inside of these structures are to collect samples and actually analyze these samples in a lab. But the problem by doing this is that we're now opening up and risking further corrosion due to exposing the insides to increased or hostile marine environments rather. So the method proposed in my research combines propagation of acoustics as well as the physical properties or parameters rather of the BioStol model to develop a non-destructive technique for detecting cracking inside of corrosion. So to do this, we have our test set up in figure 1, where we take a concrete sample which has 2 rebars that are embedded within it, and place a transducer about 12 centimeters above the concrete surface. Now from here, what we do is we send acoustic waves which penetrate the concrete as well as the rebar, giving us 2 echoes of the concrete and the rebar. And then we place this through a simulation which will actually output, using the geostole parameters, some interesting data, one of which is plotted in figure 2. Now, one of the parameters that we were studying is the concrete rebar interface depth, which is the distance from the top of the concrete to the top of the rebar. And this parameter is important to us because due to the nature of rebar corrosion and reinforced concrete structures, there's a tendency for the concrete to displace upward from the rebar, meaning that that distance will increase. So for our initial trend analysis, in table 1, what we found is that in the earlier samples, so sample 1, which has less corrosion, moving up to sample 3, which shows the most significant amount of corrosion, that on average, the distance between the top of the rebar and the top of the concrete actually increased as we showed, or we studied samples with increased corrosion, meaning that the anticipated trend was shown. Now, future research will look at the remaining parameters of our model, and then the hope is to take the trends from that and compare that to the traditional techniques such as the galvanostatic pulse measurements we collected, and to optimize the model such that we can use it in real-world applications, whether that's for bridges or just general concrete pilings.
Thank you, Samuel. If it isn't obvious, I am not, did not get my master's in engineering or science, so I was trying to pronounce polar elastic in my mind 20 times before I introduced Samuel and his subject. So now we will be going on to our last contestant in a moment after the judges are done scoring. And we'll be wrapping up soon. Thank you guys very much. Our final competitor is Fangming Qu from the College of Engineering, presenting on toward vehicle occupant invariant models for activity characterization. Fangming, are you ready?
Take the stand out of your way. You make sure it's still on. Does it still say it's on? Yes. Okay, perfect.
Hello, everybody. My name is Fangming Qu. You can also call me Ming, like the Ming Dynasty. I'm born and raised from China. I'm here a graduate student doing researches about artificial intelligence. With my mentor is Dr. Merdad Nojmin. And I'm here to do research to solve real-life problems. So our study name is called Toward Vehicle Occupant Invariant Models for Activity Characterization. It sounds really hard, but in a simple way, it's the detection of the driver behavior inside of the car using AI. And so what is the problem? The problem is that there's a lot of drivers falling asleep behind the wheel. Drowsy driving, text driving, drunk driving, etc. In 2021, 91,000 accidents caused by drowsy driving. And every year, there's more than 6,000 deaths happening in the US. But we're here to use artificial intelligence to help to solve the problem. So what is AI? In some way, AI is a flexible tool. We can use it to mold the tool to help to solve our problems. And it's only for our benefit to help us. But before we do that, we have to train the AI. AI is kind of like an invisible person. So for a complete practical training course, we have to use models trained with data sets. What is a model? Model is a learning method for the AI to learn. Like for us, we learn things in different ways. And for this topic, we prefer the method that's called three-dimensional convolutional neural network. It's a method of deep learning. And for the data sets, it's a learning material we present for the artificial intelligence to learn. And this one, we use gesture data set and HDMB. It's more about the facial expression and the subtle movement of the driver inside of the cabin. And so, after this research, what is our application? So for us, it is enabled us for a more safe driving experience for drivers. Also for DMV, it can help to evaluate the driver's driving score. And this is my research. And thank you for all. Thank you for listening. Hope you can learn a thing or two from this presentation. And my name is Ming. Thank you.
Thank you, Ming, very much. And that concludes Heat 2. So as our judges continue to score, we are going to relax, first of all. You all did a great job. I'm going to relax. You all should as well. And while we're doing that, our attendees may vote for the People's Choice Award winner. Please scan the QR code on the screen. And select the competitor that you feel provide the best presentation. As a reminder, the items to keep in mind when voting are comprehension and content, presentation provided clear background and significance to the research question, presentation clearly described the research strategy and the result of the research, the presentation clearly described the conclusions, outcomes, and impact of the research. Also, engagement and communication, the oration was delivered clearly and the language was appropriate for a non-specialist audience. The PowerPoint slide was well-defined and enhanced the presentation. The presenter conveyed enthusiasm for the research and captured and maintained the audience's attention. And our scoring calibration, 1 being that the presentation did not meet your expectations, and 7 being that the presentation was absolutely amazing and flawless. We'll give you guys a few minutes to put in your votes, and then afterwards, we'll close your voting, and go ahead with the award ceremony.
You guys may vote as well. Yeah, absolutely.
Oh, yes,
Sure.
sorry.
Everyone in the room.
Everybody in the room can vote. Everyone. So please feel free.
It's for the People's Choice Award.
People's choice, you want all people. There could be some people in the audience. Don't want to offend anybody.
Just can't take a picture. I want each of you to have a chance to vote, and then we're gonna do a group photo before we announce anything. You should just be applaud your camera, and as soon as you open that QR code.
Oh, sorry, guys.
It tells you to go to the form.
It's so long.
You know what? I'll do it.
You send me this.
Yeah, absolutely.
That also did the best thing that I got was after I left. That was really nice. I really appreciate it.
May we have all the competitors to the stage for a group photo before we announce the winners? And please vote for yourselves, obviously. Or if you really wanted to vote.
Now?
Yeah, come on.
Yeah, please, we're gonna do all 6 of you on the stage. So the 3 of you that are lined up on this side, I want you to kind of face the other side. That'll make a little bit more room, and then we'll get all 6 of you in between these 2 banners. So 3 on this side are gonna be facing this way, the 3 on this side are gonna be facing this way.
Oh.
That way it'll just make a little bit more room.
So like this, you mean?
Yeah, like at a slight angle, that way we'll fit in a little bit tighter, and then we can get these banners to both sides of it. So there should be 3 and 3 to each side of that middle divider. Wonderful, wonderful. Get a little bit closer. All right. This is the main photographer, so keep smiling toward him. Wonderful. Got some good ones? Yeah, wonderful. Give it up for the competitors, everybody. Thank you, thank you, thank you, thank you.
Yeah. Twice.
Or it's a fire machine.
Very.
It's a fire. It's
Yeah, that's easy.
Yeah, we're gonna get plugged in. But this is it, right? It's just to make it submit everything. That's right. You need to charge him with an That's interesting. Actually, this lady, Brianna must be wrong. No, this is just it. So the winner is.
Yeah, just so you don't have to. I tried it in the first one and moved.
There's
Shut
one.
my head out too.
Yeah, you hear.
So before we give out the awards, I want to thank you all for competing again. This has been an amazing experience for myself. Going to be my first heat. And thank you to our judges for participating. We really appreciate you guys coming out and dedicating your time to your students. So our second runner-up is Dominic.
Dominic. There you go. Thank you. You want to don yourself with that? You then photo with Steve.
Oh, sure.
Yeah, and this is yours as well. Thanks. Yeah, absolutely. Ready? Cool. All right. Congratulations again.
I'm going to not use the mic. Is that okay? Thank you. Our runner-up is Ingrid. And our winner is Hayley.
You're welcome. This is yours as well. Congratulations. How's that going? Oh. Cool. Perfect.
Maybe actually, because you also are the People's Choice.
Further?
Yeah.
Yeah.
One more time, please. Awesome.
Thank you all again. We're also again hosting Pete's tomorrow is from 10 to noon, and then 2 to 4, and then on Wednesday is 10 to noon. And then our championship is going to be on Friday night at 6 p.m. Is it going to be held here?
It's going to be in the student union, the Grand Hall.
All right, perfect. All right, guys, thank you so much again for participating. Congratulations to the winners, and best of luck with your education.